Hi, and welcome to Chapter 4. Chapter 4 is going to get into this thing called decision structures, which is kind of the meat and potatoes of program languages, because what it allows us to do is we give the program a choice, and they can take the choice of either true or false. So basically, when we give the computer choice, we have to give it what's called a Boolean decision, which is basically true or false. So I might say, is A greater than B? Is that true or is that false? And so that's basically the whole basis behind the decision structure. So we come in here and for example, we may have declare an integer age, display what is your age. We get the age and we say here's the value entered. Well, what if we wanted to basically have some type of decision of whether to do something or not? So here's a flow chart where is it cold outside? If it's cold outside, if that's true, we're going to say wear a coat. False, we're not going to do anything at all because you don't need to put on a coat. So here's just a basic flow chart. We come in and we say go to the window, read the thermometer. Is it cold outside? If that's true, you put on a coat. If false, you don't do anything at all. Then you open the door, you go outside, end of the program. Okay. We could take it a step further with inside of our decision structure. If it's cold outside, we wear a coat, we wear a hat, we wear gloves. Okay. So the way we do this in pseudocode is we have what's called an if statement. If some condition, if that's true, we can do all these statements we want, and we do an end if. Okay. We can do greater than, we can do less than, greater than or equal to, less than or equal to, we can do equal. Now, in programming languages, there's a big difference between an equal sign and a double equal sign. An equal sign is majority of the time what's called an assignment statement. I want A to equal 11, so I'm basically putting 11 into the variable A. So in this particular case, though, we're trying to see, does A equal B? And to do that, we just put a double equal sign. And that basically says, hey, I'm trying to compare these two. So a single equal, for the most part, is an assignment operand, whereas two equal signs is a comparison operand. Now, I say that because most languages, again, have that feature, whereas Raptor does not. Raptor, we use an equal sign for comparison and an assignment as well. But just keep that in the back of your mind. And then we have an exclamation point equal. That is not equal. Okay. Some languages have the greater than and the less than symbol, and when they have those two side by side, that basically is stating not equal. And Raptor's case, we're going to be using the exclamation point equal sign. Okay, so let's see. So it talks about the greater than or equal to and the less than or equal to. Realize if you say is A less than 2,000, if A is 2,000, that's not going to be a true statement because A is equal to 2,000, but it's not less than 2,000. So if we wanted to include 2,000, I would need to say is A less than or equal to 2,000. It says when programming languages, it uses the double equals as the operand. Take care not to confuse the operator with the assignment operator, which is the equal sign. I've talked about that earlier. Languages such as Java, Python, C, C++, they use the double equal sign, the compare to operand, as opposed to just the single equal sign as an assignment. The exclamation point equal sign is the root of the not equal operator. Again, that's probably for most languages as well. So if we look at it in pseudocode, I have if sales are greater than 50,000, then set bonus equal to 500. So if I've created a variable called bonus and I set it to 0, if the sales happen to be $60,000, bonus would now have $500 in it. If the sales were only 40,000, bonus would still only have 0 in it. Okay. We may say sales greater than 50,000. We set the bonus to 500. We set the commission rate to 0.12, and it would display you've met your sales quota. Okay, so this is what it would look like in a pseudo or a flow chart. Okay, so the very first thing we're going to do is we're going to jump in and do in the spotlight. And it says Catherine teaches a science class and her students are required to take 3 tests. She wants to write a program that students can use to calculate their average test scores. She also wants the program to congratulate the student enthusiastically if the average is greater than 95. So here's the algorithm. So first we get the test score. We get the second test score, we get the third test score, we calculate the average, display the average, and if the average is greater than 95, we congratulate the user. Okay, so here is the pseudocode. But before we do that, let's just jump in and let's actually do a decision flow within Raptor. So let's say I'm going to come in here and I'm going to say that age is equal to 0. And make me save it. So then I'm going to come in here and grab some input. I'm going to say how, double quote, how old are you? And we're going to throw that into age. Okay. And then I'm going to put a decision structure. So Raptor calls it selection, but it's this decision structure. So I click on that and I put it right down here. Now I double click on this diamond and I'm going to say age greater than 50. And if it is, I'm going to display, so on the yes side, I'm going to display, man, are you old? Okay. And then I'm going to put another one on the no side that says, you still have some years left. Okay. So this is basically the flow of our program here. I come in, I create, I forgot my comment to say this is an integer. So how old are you? Here's the decision structure, greater than 50, so let's run it. So how old are you? It says, man, are you old? Okay, so I run it again. How old are you? I'm going to say 40 this time, and it says you still have some years left. So again, so it's a decision. It says, is the age that we typed in greater than 50? If it is, we're going to basically do what's on the yes side. If it's not, that's false. We're going to do what's on the no side. So here is this particular program. So let me go ahead and open that. And so here it is. I declare a variable called test 0.0. It's a real data type. Test 2, test 3, and an average. Those are all initialized as 0.0 and they're set to a real data type. I say get the score for test 1. We get that. I get the score for test 2, test 3, and then I have a assignment box where I go ahead and say average is equal to, notice I have the parentheses where I add test 1, test 2, and test 3 together. Then outside the parentheses I divide by 3. And I say if the average is greater than 95, congratulations, great average. I display that, else I do nothing at all. Okay, so there's nothing on the no side. So I run this and it says test score 1 we'll say is 90, 99, and we'll say 97, and it comes up and says congratulations, great average. Okay, but if we run this again and I put in 90, 89, and 92, basically nothing came up. It just shows the run completed and that was it. So here's basically the flow chart that we just created. We get the scores. We then basically do the calculation of the average. We display the average is. Oh, they wanted us to display what the average is. Okay, I did not do that there. So let's do that real quick. I can add that right here. double quote, the average score is ending quote plus average. Okay. So let me save that. Let's run it again real quick. So I type in 99, 91, 97, and it comes up and says the average score is 95.666. Congratulations, great average. Okay, so it basically works the way it needs to. Okay, so that's a simple decision structure. Now, what happens if, again, the weather, in this case, the weather is, we determine what type of weather we're having. We basically are going to determine whether the temperature in Fahrenheit is less than 40. If it is, we're going to say nice weather we're having. I'm sorry, if that's false, what nice weather we're having, so it means it's greater than 40. Else it's a little cold, isn't it? Okay. So in pseudocode, we would have if, and now in pseudocode they use the word then. We actually use the word then in COBOL, and I believe VB. We actually use the word then. In Java, we just have if and else is what we use, open braces, and I believe C++, and Python all use the same. They're pretty close in syntax as far as language. So here's what we have. We have an if-then-else statement. Okay. Chris owns an auto repair business and has several employees. If an employee works over 40 hours in a week, Chris pays that employee 1.5 times his or her regular hourly pay rate for all hours over 40. Chris asks you to design a simple payroll program that calculates an employee's gross pay, including overtime wages. So the algorithm we need is we first need to get the number of hours worked. We get the hourly pay rate. If the employee worked more than 40 hours, we calculate the gross pay with overtime, otherwise calculate the gross pay as usual, and we then display the gross pay. So here's how we're going to do this. We're going to do this with procedures. So we're going to have a procedure called get hours worked, and we're going to pass in the hours and get back the hours. We're going to call the get pay rate, where we pass in the rate. I don't think we need to. I think we get the pay. Yeah, we get the pay rate back. Calculate the hours with OT. So we get the hours. We calculate regular pay. Okay. So here's the basic flow chart. We declare our variables, which is hours worked, pay rate, and gross pay. We call get hours worked, so that's going to return the number of hours we worked. We get the pay rate, returns the pay rate. And then we say the hours, if the hours worked are greater than the base hours. So we're going to have, we are going to need base hours set somewhere. Oh, okay, they have base hours set up as a global. Again, we can't do that. So that means we're going to have to pass that constant base hours to each one of these items down here for the calculation. So if it's greater than base hours, we then go ahead and calculate regular pay. If it's greater than base hours, we're going to calculate the overtime, and then we're going to display the gross pay outside of this. So if we take a look at this in Raptor, so we basically we created a constant integer called base hours, and we set it to 40. We created an hours worked, which is real. We set it to initialize to 0.0. We created a pay rate variable, set it to 0.0. Gross pay, set it to 0.0, and then we call get hours worked. So I get hours worked. Now before I go in here, let's take a look at the procedure. I am passing in hours work, and I'm receiving it back because we set it for input and output. That means it's going to send it there, and we're going to get it back. Okay, so all we do is we just basically display the input box. Hey, enter the number of hours worked. We get that, and then we go back to the main. Then we call get pay rate, where I pass in the pay rate variable. The pay rate, again, is going to get the pay rate. We're going to get it in. We're going to pass it back. And all we're doing there is basically saying enter the hourly pay rate, and we get that. So we call those two procedures. We now have the hours worked. We now have the pay rate. We then check if the hours worked are greater than the base hours. We are going to call, so if that is true, so it's on the yes side, we're going to call the calc pay with OT. We're going to pass in the hours worked, the pay rate, the gross pay, and the base hours. Okay, we have to do that since we don't have a global variable we can use here. Now, when I look at calc pay I'm going to look at the modified procedure here. Notice that I'm passing in hours worked, the pay rate. The only thing I'm passing back is the gross pay. Okay, I don't need to pass back hours worked. I don't need to pass back the pay rate, and I don't need to pass back the base hours. All I really need to do is pass back the gross pay. So I go ahead and I create a constant within here. This is a local variable. It's called OT underscore multiplier, and it's set to 1.5. I create another variable, again a local variable, just to this procedure called overtime hours, and I initialize to 0.0. I create overtime pay, set to 0.0. I say overtime hours is equal to hours worked times, or hours worked minus the base hours. Okay? So now I have just the overtime hours. The overtime pay now is equal to the pay rate times the OT multiplier, so the pay rate times 1.5, and then we multiply whatever that is times the overtime hours. So now I have overtime pay. Now I'm going to have gross pay, and that's equal to the pay rate times the base hours, so whatever the standard pay rate is times 40, and we're going to then we are going to add the overtime pay to that. So now what we're going to get back then is the gross pay from that procedure. Now, to calc regular pay, if I look at those procedures, notice I'm just passing in hours worked, pay rate. The only thing, again, I'm passing back is the gross pay. And all it's doing is saying gross pay is equal to hours worked times the pay rate. That's it. Okay? So when we get back to main, this last thing it's going to say, the gross pay is whatever that gross pay is. Now, to check this, so here's what we would have to do to check this. Let's first run it, and we're going to say they work 35 hours at $10 an hour, and the gross pay is $350. So I make sure I picked some really nice, easy to calculate in our head type of numeric values to utilize here. So let's do this. Let's run it again, and we're going to say 45 hours worked, and the gross pay is 10, and it's $475. Now, to check this out, what we need to do is this: we need to grab a calculator, and we need to say that, okay, so we know what the base pay is for the $10. That's $350, right? So we know that right off the bat. So they worked 5 hours of overtime because I put in 45. So I would take the pay rate, which is 10, and I would multiply that times 1.5, and that's equal to $15. I would then take that times 5, and that ends up being 75. Okay? So 40 hours, I'm sorry, I'm sorry. I was looking at, talk about the old one, 35. Okay, that's 350. So right now the base pay is 40 hours times 10, which is 400. Our overtime is $15 an hour times 5, which is 75. We add that to the base pay, which is now $475. So we just checked this. It checks out right. So we ran this both ways. We basically used a calculator to prove that yes, the program does work. Okay, so here it is in the flow flow chart. So here is this program as pseudocode. Again, you can look at that within your book. So now we want to talk about, so we've looked at comparing numeric values, which is very, very easy. Let's talk about comparing strings. In here it says we're going to have a string name named Mary and another one named Mark, and when I compare those two, how does the computer actually compare those items? So what it does is this, is it looks at the very first two characters. If they are equal, it then looks at the next one. But if one is larger than the other, now what is larger? Well, I don't know if we talked about this in chapter 1, but every character has an ASCII value. There's ASCII is ASCII. That's an acronym for, I don't know, some type of area that came together and decided to put, what particular values are equal to this particular binary. It actually goes from 0 to 255. So there's 256 different characters available to us. Now, if you think about the alphabet, we have 26 uppercase and 26 lowercase. We have 10 numeric values, 0 through 9. So what is that? 26, that's 52. That's and then 10, which is 62, there's 62 characters. Well, then we got periods and pound signs and slashes and space, commas, we got all those types of things. But that's still not going to add up to 256. There's a lot of unprintable characters like line feeds and carriage returns, and there's a few other things, and there's a lot that aren't used at all. So just realize that there's 256 available characters for us to use. Now I'm telling you all this because each one of those items has an ASCII or hexadecimal value. So when I look at the capital letter M and a lowercase m, hexadecimally, one is larger than the other, and that's really what the computer is looking at. So in this case, we got Mary and Mark. So it looks at the first two letters. They're both uppercase M's. Those are equal. And then goes to the next letter. Both are lowercase A's. So they're the same. Next letter is uppercase R or lowercase R's. Both the same. And then it gets to the last letter. A lowercase k and then a lowercase y. The y is going to be larger than the k, so Mark is going to be less than Mary in this case. Okay, so let's take a look at program 4-3. And this is a password program. So we're going to create a string called password. We're going to initialize it to a null value, which is 2 double quotes side by side. And then I say enter the password. And then I have my decision statement that says if the password is equal to PROSPERO, all lowercase, if that is yes, we're going to say password accepted. If it's no, we're going to say sorry, that is not the correct password. Okay, so we run this. I just will type some gibberish in there. It comes up and says sorry, that is not the correct password. So I run it again, and this time I type in PROSPERO, and it comes up and says password accepted. Okay, so just kind of a generic run-of-the-mill password decision, whether it's true or false. Okay, so this is kind of what this other string comparison is talking about here. It says the uppercase characters A through Z are represented by numbers 65 through 90. Those are hexadecimal numbers. The lowercase letters are A through Z, and they're represented by 97 through 122. So lowercase in this case is going to be greater than an uppercase letter. Okay, so if I came in here and said if A is less than B, then display the letter A is less than letter B. Okay. And again, that's where it kind of comes in, and this is where it basically looks at the uppercase M and uppercase M are both 77s, lowercase a is a 97, lowercase r is 114, and then it got the y, 122 and 107. So the mark is going to be less than Mary. So we take a look at program 4-4. And here we are going to get create two name variables. We've got name1 initialized to a null value, name2 initialized to a null value. These are set to string data types. Then I say input box, enter a name, last name first, and enter another name, last name first. So it looks as though we want this to basically, I guess we're going to put the last name first name, okay? And then we're going to put the names in alphabetical order, okay? So if name1 is less than name2, we are going to then put name1 first and then name2. If that's false, we're going to put name2 first and then name1, okay? And then we basically end the program. So it's a very, very simple sorting program between just two items. Is this one larger than this one? If so, we're going to put the smaller one first and then the big one. If it's vice versa, we're going to put the first one the first one first and the second one second. Okay, so I run this. It says enter a name, last name first. So I type in Webb, comma Judy. I put Webb, comma Mark. I run this and it comes up and says here are the names in alphabetical order, Webb, comma Judy, Webb, comma Mark. Okay. So if I did that just in reverse, where I run this, I'm going to type in Webb, comma Judy. No, I'm sorry, Webb, comma Mark, and then Webb, comma Judy. It still put it in the correct alphabetical order. Okay. So now, we're going to try to get a little more detailed here where we're not going to have a decision inside of a decision. So in this particular case, we need to find out if someone's qualified for a loan. If they have to have a salary greater than or equal to $30,000 a year, and they have to be on their job 2 years or greater in order to get the loan. Okay, so here's a basic flow chart where we have a salary check. If their salary is greater than or equal to $30,000, we're going to go into this true side, and now we're going to check their years on job. If that first statement is false, we're not even going to go into that. We're going to come over here and say you must earn at least $30,000 per year to qualify, and then the program ends. Okay, so notice that we just go straight into false and straight over here to end. Okay, there's no second chance of getting in this second decision structure. There's only one way in that decision structure, is this has to be true to get to this decision. Now, if they make over 30, if they make equal to 30 or greater than $30,000 a year, we come into years on the job. If they are on their jobs more than 2 years or more, we're going to display you qualified for the loan. If that doesn't happen, we're going to display this on the screen. You must have been on your current job for at least 2 years to qualify. Okay. So we take a look at program 4.5, which is going to be this exact program. And so here we are. I create a salary and initialize to 0. Real data type. Years in the job variable set to 0.0. Real data type. I then have my input box where I say enter your annual salary. I get the salary. Enter the number of years in the job, and I get the years on the job. Okay. And then first thing I do is I say is salary greater than or equal to $30,000? If it is, I'm going to come over here to years on the job and check that. If the years on the job is greater than or equal to 2, we're going to say you qualify for the loan, and then we're going to come straight down here, boom, straight down here, and end the program. If they make more than $30,000 a year, but they've only been on the job for less than 2 years, we come over here, we're going to display you must have been on the job, your current job, for at least 2 years. We come down here, come down here, come down here, end the program. Okay. Again, if they've been making less than $30,000, we say you must earn at least $30,000 per year to qualify. Boom, down here in the program. So I run it. I'm going to say they make $31,000. Been on the job for 3 years, and it basically says you qualify for the loan. So let's run it again. This time they make $31,000. They've been on the job for 1 year, and it comes up and says you must have been on your current job for at least 2 years to qualify. So let's run it again. This time they make 29,000. Into years in your current job is 3, and it comes up, says you must earn at least $30,000 per year to qualify. Okay, so as you see, I did 3 different tests to make sure that this program worked correctly. Okay, so here is in the spotlight. We are going to create a grading program. If the student has a 90% or above, they're going to get an A. If they have between 80 and 89%, they're going to get a B. 70 and 79% a C. 60 and 69% a D. And below a 60, you're going to get an F. Okay? And so this is the flow chart they're going to use. Now, I probably would have done this differently. I probably would have started with the score greater than or equal to 90 and then went down from there. Well, they're doing just the opposite. If your score is less than 60, if that's true, you get an F. If that's false, we're going to have our next nested if that says if the score is less than or equal to 70, we'll display a D. If that's false, we're going to do the 80. Now, the great thing about this particular flow chart is, as compared to mine, is I would have to use an AND statement, and we'll cover that a little bit later. But this is a little easier to program because we only have to have one if statement, one selection statement per diamond there. Okay, so let's just take a look at this in Raptor. Let me maximize the screen. So this is what it looks like. I create a score variable. I initialize to 0.0. I then say get your test score, and I put it in there. Then I come in here and I say if their score. Now notice that Raptor kind of flip-flops things than what we see in the book. In the book, the true is on the right-hand side and false is on the left, where in Raptor, true is on the left-hand side and false is on the right. So we check. Is your score less than 60? If it is, your grade is an F. If that's false, we check to see if your score is less than 70. If it is, you got a D. And we know you didn't get 60 because 60 has already been determined. So really what this is saying right here is score less than 70 and greater than or equal to 60. Okay, that's really kind of what that's saying. Okay, so if that's false, we check to see if it's less than 80. If that's false, we check to see if it's less than 90. If it's less than 90%, you got a B. If it's greater than 90, you get an A. Okay. Well, really what that's saying is if it's greater than or equal to 90. Because if it's less than 90, it's a B. If that's not true, that means it's greater than or equal to 90. You get an A. Okay, so we run this. They got an 82. It comes up and says your grade is a B. Exactly what we expected. Okay. And again, I could test this for less than 60, less than 70, less than 80, less than 90, or greater than 90. So if I ran this again and put they got an actual 90, it comes up and says your grade is an A. So, a really cool nested if program. Nested if, nested if, nested if, nested if. So let's take a look. Now, this is an option that we do not have in Raptor, and that's called an else if statement. Now, notice if you compare this pseudocode right here to this pseudocode, notice how everything kind of stays straight. So with an if-else statement, we would say if score less than 60, else if, so we got the if built into the else statement. That's really all that it's doing. And that we can utilize the if-else in most all programming languages out there today. We just can't do it within Raptor. So just realize that that is not really available to us in Raptor, but it will be available once we get into the programming language beyond this course. I'm not going to go into 4.7 because again 4.7 in Raptor because it's not available. I think I have it there, but it looks identical to 4.6. So case structure, same thing with the case structure. We do not have a case structure available to us in Raptor, but here's how a case structure works, and it's available to us in most all programming languages. We have what's called a select and then our case. So we have a select, which is our test statement. Then our case says, if it's equal to this, do this. Okay? So in this particular case, we got month. If it's a 1, we display January. If it's a 2, we display February. If it's a 3, we display March. Else, everything else would display error invalid month. Okay? So this is how we would do it within a flow chart. Yeah. So again, here is 4.8. They want us to say the model number. If it's 100, do this. What 200, do that. 300, do that. Else invalid model number. And again, if we look at this in Raptor, it's going to be, so I create a model 100 price, which is 199.99. That's a constant real. A model 200 price, 269.99, constant real. Model number 300 price, 349.99, which is a constant real. And then I've got model 100 size, which is 24, and that's a constant integer. Model 200 size, which is 27, a constant integer. Model 300 size, which is a 32, constant integer. And then I set the model number equal to 0, which is also an integer. I then get the input from the user, so I tell them to type in a model number. I then say, if the model number is equal to 100, if that's true, I display that. Else, I check to see if the model number is equal to 200. I display that. Else, I check to see if the model number is 300. If that's true, I display that information. Else, I put that is an invalid model number. Okay. So I run this. I type in 100. It said the price is 199.99, size 24. Run it again, type in 200. It comes back and says the price is 269.99, size is 27. Type in 300. It comes back and says that price is 349.99, size is 32. I'm going to type in 400 this time, and it comes back and says that is an invalid model number. Okay? So, select case, great procedure to use, but in our case we cannot use it in Raptor, so just realize it's just not available to us. Okay, so let's go on to the next section. So now let's take a decision structure and let's check to see, do we have something equal to something else and something else. This is basically called Boolean logic. Now, Boolean was a guy back in the 1800s, and he developed these different logical operators that, talking about electricity, maybe even plumbing. You know, if this valve is on and this valve is on, which way is the water going to flow? If this electrical switch is on and this electrical switch is on, which way is it going to go? So we basically have 3 logical operators. We got and, or, and not. So when we use the Boolean and logical operator, what that says is if I have a comparison between these 2 items and these 2 items, in order for that entire thing to be true, this has to be true and this has to be true for the entire thing to be true. With ORs, this has to be true or this has to be true. That means if this is true and this is false, the entire thing is still considered true. Only one of those items has to be true for the whole thing to be true, because it says or. And says everything has to be true, or says only one of the items has to be true. So the AND operator. So If one's true, one's false, it's false. If one's false and one's true, it's false. If one's false and one's false, it's false. If one's true and true, it's true. With the OR operator, we say if it's true or false, it's true, because one of those items is true. If one is false and one is true, it's true. If one is false or false, they're both false, then it's false. If one's true and one is true or true, it's true. Okay? So, we also have what's a not logic, and I'm not a big fan of not logic. So, if not temperature greater than 100, that's really hard to understand. What we'd actually say there is if temperature is greater than or equal to 100. Okay, so not logic is really, there's sometimes we can't avoid not logic, but we can try to avoid it when all possible. So let's go back to our loan qualifier program and let's take a look at that using ands and ors. So I come in here, I'm going to open up 4.9, and so first thing we do is we have a salary. We set it to a real data type at 0.0. We have years on the job set to 0.0. We get our annual salary. We get our current years on the job. So up to this point, it looks identical to the last one. This time we have one decision where I say if the salary is greater than or equal to 30,000 and years on the job is greater than or equal to 2, if that's true, we say you qualify for the loan, else we say you do not qualify for the loan. Now, the big difference between this flow chart and the previous one is we cannot display to the user why they didn't get the loan. In the previous one, we would display you don't make enough money or you haven't done the job long enough. Here we just say you don't qualify for the loan. But you notice how short the program is using the Boolean logical operand and. Okay, so again, these both have to be true for the entire thing to be true. So what we do is this: we go ahead and run this. I'm going to type in 31 and 3, and it says you qualify for the loan. I run it again. This time I'm going to type in 31 and 1, and it says you do not qualify for loan. We don't know why. So as a user, I would see that, I wouldn't know why. So we run it again. I type in 29 and 3, and again, we don't qualify for the loan. So, okay. So ands and ors. So let's do the next one, which is the same exact program, except this time we're going to have an or in there. So we open up 10, and here it is. So same exact program, salary greater than or equal to 30,000 or years on the job equal to 2. Okay, only one of those has to be true to basically qualify for the loan. So this time I'm going to run it again. Okay, so I type in 31, I type in 3, you qualify for the loan. Run it again. I'm going to type in 31,000 and 1, and we qualify for the loan. So I run it again, 29 and 3. We qualify for the loan because again one of those is true. So let's run it one last time. I'm going to type in 29 and 1, and you do not qualify for loan. So again, so with the or, only one of those had to be true, and you can see we qualified, we qualified, we qualified. The only time we didn't qualify when they were both false. Okay, so an or statement is a great statement, so it's a way for us to combine. So instead of doing two nested ifs, we can have just one if statement to basically get the particular decision structure that we need. It's great for checking ranges. I could say if x is greater than or equal to 20 and x is less than or equal to 40. What that's basically saying is, in that just one statement, it has to be between 20 and 40. Okay, because if it's less than 20, it's not going to basically set that to true, and if it's greater than 40, it's going to basically set that not to true. So one of those will be false, and basically not be that whole entire if statement will not be true. If I said less than, if x is less than 20 or x is greater than 40, so now this is a different kind of range. I do not want them to select between 20 and 40. I want them to pick a number that's less than 20 and a number that's greater than 40. So I would use an or in this case. Okay. I cannot say if x is less than 20 and x greater than 40. That will never, ever, ever be true, because we can never have both items be greater than and less than something else. Okay. Boolean variables. Now, Boolean is a data type that is either true or false. So I could actually say, I'm going to declare a Boolean data type called isHungry, and I'm going to set isHungry to true, or I can set isHungry equal to false. So if sales is greater than or equal to 50,000, then set the sales quote met equal true. Else set the sales quota met equal false. Okay? Then I can say if the sales quota was met, you have met your sales quota, or else you have not met your sales quota. They don't have any examples here, but I created one where I have qualify equal to false, salary equal to 0.0, years in the job equal to 0.0, enter your annual salary and enter your current years in the job, and I'm going to say if your salary is greater than or equal to 30,000 or years on the job is greater than or equal to 2, I'm going to say qualify equals true, else qualify equals false. Now here's something I want you to pay close attention to. I really don't need to say qualify equal false because I already initialized it to false. So I could just not even do anything on that side, but I wanted to make sure we have that example in there. Then I have another decision that says if qualify equals true, you qualify for the loan, else you do not qualify for the loan. So let me just run just one item through here. So 31 and 1, and it says you qualify for the loan, because again, if we look over here, qualify was set to 1. 1 is true, 0 is false. So true and false is either 0 or 1, or it's true or false. Okay, I believe that's it for the chapter. So if you have any questions, please contact me. Let me get those, help you with anything. We can Skype, text me, whatever the case may be. We'll see you at Chapter 5.